Now we have almost come to the end of this topic. We'll end this particular topic with triple vector cross product. It can be called triple vector product or triple cross product, anything. So what is it how is it defined? Consider three vectors and cross A, B and C, and we define A cross B cross C as equal to B into A dot C minus C into A dot B. So there's a shortcut way to remember it. Just remember back minus cab. So B into A dot C minus C into A dot B. All three A, B, C being vectors. What it basically represents is, it actually doesn't represent any volume. So B cross C actually has a direction perpendicular to the plane containing B and C, right? And A cross B cross C means a vector which is perpendicular to both A and B cross C. So it is basically giving us a vector which is perpendicular to both the plane containing A and B cross C's resultant. So it is not representing any volume as such, but it is just giving us a vector. And it also does not represent does not follow associative or commutative law, that is A cross B cross C will never be equal to A cross B cross C. So for example, let us consider graphically that this axis represents A and this axis represents B cross C, a vector which is perpendicular to to the plane containing B and C. So then triple cross product will have a direction either into the plane or out of the plane, whichever way we take it. Either we take A cross B cross C or we take B cross C cross A. So again we determine this direction with that right hand thumb rule. If our fingers, apart from the thumb, if our four fingers point from B cross C towards A, our resultant will be directed out of the plane, outward towards us. And if we go from A towards B cross C, that is A cross B cross C, then our resultant will be directed into the plane, that is on the other side, towards the other side of the board. Now let us look into some of the identities of vector algebra. So just remember them as identities. Identity number one would be A cross B dot C cross D is nothing but A dot C into B dot D minus B dot C into A dot D. Alright. And the next identity being A cross B cross C cross D is equal to scalar triple product of ABD minus into C minus scalar triple product of ABC into D. So it is nothing but A dot B cross D into C minus A dot B cross C into D. Now let us do some sums. The question says, question number 1. The question says that if A is equal to I cap minus j cap minus 2k cap and B is equal to 3i cap plus 5j cap plus 6k cap and C is equals to minus I cap plus 4j cap plus mk cap, then we need to find the value of m such that the vectors will be coplanar. So what does a coplanar what does coplanarity mean? That scalar triple product of A, B and C, that is A dot B cross C, should be 0. Now we have been given vectors with components. So the easiest way to find the scalar triple product is to write it in its matrix form. So what is the coefficient of I? 1, 3 and minus 1. 1, 3 and minus 1. What is the coefficient of J? It is minus 1, 5 and 4. What is the coefficient of K? It is minus 2, 6 and M. So minus 2, 6 and M. And this should be equal to 0, and only then will A, B and C be coplanar. So how do we solve it? We solve it in the easiest matrix solving way. So it will be 1 into 5m minus 24 plus minus 1 into minus 6 minus 3m plus minus 2 into 12 plus 5 is equals to 0. So we an implies sign. Now this implies that 5m minus 24 plus 6 plus 3m minus 24 minus 10 would give us 0. So 5 plus 3 is 8m minus 48 minus 4 is equals to 0, which gives m is equals to 52 by 8. which gives m is equals to 6.5. So this is our answer. So for if the value of m turns out to be 6.5, only then will a, b and c be coplanar. That is, all a, b and c vector will lie in the same plane. So that's all for now. Let's meet in the next video.